Hey everybody, so in this video we are going to be simplifying complex fractions. So you'll notice that what we have here is what's called nested fractions. This is when you have fractions inside of fractions. So what we want to do is take this numerator and to write it as one fraction and then divide it by this denominator written as one fraction. So here's what we'll do. We'll work with the numerator first and we'll go ahead and try to reduce this to one fraction. To do so, you need common denominators. The easiest way to do this is to use cross multiplication. So we'll say 27 times x to the third. That gives us 27x to the third. The sign in the middle never changes. So we'll bring that up here. And then y to the third times 1 is just y to the third. Now we multiply our denominators. Y to the third times x to the third is y cubed x cubed. Now we're dividing this numerator by the denominator. And here you see we have two fractions, so we'll do the same thing. We'll cross multiply and say 3 times x cubed y squared. The sign in the middle never changes. And then x squared y cubed times 1. And then we will multiply straight across to combine our denominators. So that's going to be x squared y cubed times x cubed y squared. Now, when you're multiplying fractions, remember that you have to multiply by the reciprocal. So there's that little saying, keep the first, change the sign to multiplication, and then flip the second fraction. So we'll go ahead and keep the first the same, change our division to multiplication, and then we're going to flip this fraction. Now, when I do that, I'm going to go ahead and multiply my denominator here. So x squared times x cubed is going to be x to the fifth, and y cubed times y squared is going to be y to the fifth. Now from here, we would like to simplify where we can. Here I have the same variables, y and x. So I am going to let this denominator reduce this numerator by 3. So that would give me x squared y squared. Now I can rewrite. And I'm going to try to simplify here. Notice that we have x squared y squared in this second fraction. In the denominator, it looks like we'll be able to pull out a greatest common factor of x squared y squared. Now these can reduce, and what I'm left with is one fraction, 27 cubed minus y cubed, all over 3x minus y. The bottom, this denominator cannot reduce, but the numerator can. Remember in Algebra 2, when you have one cube minus another cube, we can use a rule called the difference of cubes. So here we just need to know what our base A and base B terms are. So I can look here. This is a quantity cubed, so I can take the cube root of 27x to the third, and that gives me 3x. The cube root of y to the third is just y. So I will use these terms to factor this numerator. So a minus b would be 3x minus y. A squared would be 9x squared. AB, so 3x times y is just 3xy, and then b squared would be y squared. And this will all be over our denominator of 3xy. Now these binomials can cancel, and we are left with 9x squared plus 3xy plus y squared. This will be our solution, our most simplified form of this complex fraction. That's going to be it for this example. I hope that you found it helpful. If you have any questions, please be sure to leave them in the comments, and we'll see you all in the next video.